All right, before we get into the meat of geometry and shapes and such, there are some different things that we have to go over first. Those being different properties in geometry that we use throughout the entire year. The first of those being a point. A point, like letter A down here, has no dimension, meaning it is just a place in the universe. It just holds a specific spot. When we switch into different dimensions, like one-dimensional, two-dimensional, three-dimensional, etc., it has no dimensions. It's a representation of a position in space. We could give it a position. If I put down below it like 1, 2, that is that point's position in space. It's 1 unit over, 2 units up from wherever we started. Maybe it's down here, maybe it's over here, who knows. But anyway, that's a point, and you will have to know different points. It's noted by just one letter. We can call point A just by one letter A. It doesn't have to have a name. Just one letter recognizes a point. There's also something called a line. A line is one-dimensional, meaning there is no depth to it. It goes left, right, up, down, however it wants to, but there's nothing behind it. It doesn't go off in space in a third dimension. It is represented by a line with 2 arrowheads, arrowhead, arrowhead, both extending forever. The arrowheads show you that this line is going this direction forever. Now, understand something. I can't draw it off my page, just the same way I can't draw it down off my page. The arrowhead tells you it goes on forever. It goes off forever in that direction and goes off forever in this direction. This line has 2 points on it. You need 2 points or a name to name a line. We could call this line BC, like that. Line BC. It could also be line CB, depending on how you wrote it. Maybe you're going right to left instead of left to right. If I called this L, you could also call it line L. Okay? 3 different ways to name a line. Use 2 points that are on the line, or use the line's name. The third thing that we're going to talk about right now is a plane. A plane has 2 dimensions, meaning it has a height and a width that we can recognize. We can measure those. It is represented by a shape that looks like a floor or a wall. And it too extends forever. It goes off in every direction forever, as far as you can see. The only problem is we're confined to this small piece of paper, and so we draw it with edges, even though it technically doesn't have any. We name a plane based on at least 3 letters. We can use 4, but usually 3. We could call it plane. Notice how we draw a little box. HGK. We could call it GKI. We could call it HIK, etc., etc. You could also use 4 letters, any 4 letters that are on it. Usually 3 letters is good enough. And you might say, why 3? Because 1 letter is a point, 2 letters is a line, 3 is usually a plane. 3 could also be a triangle, but in this case it's not a triangle. As long as you recognize the points that are on it. You could also say, if this had let's say this was R. This was plane R. You could also just call it plane R. Again, just like a line, maybe it has 1 name. It's line L or plane R. If you don't use the name of it, you have to use at least 3 points. Again, 1 is a point, 2 is a line, 3 can be a plane. Those are 3 different properties or 3 different characteristics in geometry that you're going to be familiar with. The sooner you understand them, the better you'll do throughout the year. And we're gonna go into further depth about them. Here's a quick picture. Okay, we have different properties inside this, and we're going to identify those. The first thing we're told to do, and number 1, is name 2 lines that you see. Name 2 lines. Hopefully, all of you can identify this. You can identify that line. Well, now we need to actually name it. One of the ways that we name a line is with 2 points. There are 3 points on that line. You can pick any 2. I'm going to use the two endpoints ST. And that's talking about that line. Now, there are different ways to name it, but since I'm talking about that line, I can't name a separate one SP because it's still the same line. I couldn't name another one PT because that's the same line. I've labeled that line, and I've labeled it ST. You could label it SP or PT or TP or TS, however. But we're already done talking about that line. There is another line, and I'm sure most of you have already nailed this one down. It's this line. And it starts off above this plane, and those dotted lines mean it's behind it. It's behind the plane so that you can't see it. Oh, and then it's solid again, so now we can see it. This part of the line is actually hidden so that you can't see it. It's hard to draw a three-dimensional world on a two-dimensional sheet of paper, but we try. Now, this line has already been named. It's line N. But you could also pick 2 points on it like QP, depending on how you want to do it. But there are only 2 lines in this drawing. There's this line right here, which we labeled ST, and you could have labeled it SP, PT, TS, TP, whatever. But we labeled it ST, and then there's also this line. Now, it could be labeled N, or it could be labeled QP, depending on how you want to do it. But those are the only 2 lines. Let's name 3 points on the same line. Well, there are only 2 lines to pick from, first of all. Are there 3 points that are on the same line? Well, first of all, there's point Q and point P. They're on the same line. N is not a point. N is just the name of the line. Unless I see a little dot next to it, just like letter A. Unless I see a dot next to it, it's just a letter that is being used. So here are 2 points. I want 3. Well, here's S, P, and T. Those are on the same line, and those are called collinear. On the same line means collinear. Co meaning the same, linear meaning line. If you're co-workers, you are the same workers at the same job, so to speak. Collinear meaning the same line. And we're going to say point S, point P, and point T are all on the same line, or SPT are collinear. And I'm sorry you can't really read that very well. Let me write it again. That is called collinear, the same line. Name 3 points on the same plane, but not on the same line. Well, now I'm looking at this plane right here. Okay, plane R, but I want to label it using 3 points. Those 3 points can't be on the same line. You might say, why not? Because if I were to label plane R SPT, then somebody might misinterpret that as the line SPT. I want to use 3 points that are not collinear, that are not on the same line. So I'm going to incorporate V. I'm going to call it V. And then I'm going to pick S and T. 3 that are in completely opposite directions and are not on the same line. Now, ST are on the same line, but as long as all 3 aren't on the same line, we're okay. And then number 4 says, give another name for line PQ. Well, we already did that. We said line N. You could also name it line QP. Okay. Make sure you understand that. I might label it a line one way. You might label it a different way, but it's still the same line. Make sure you follow that. That is one thing that as we go through geometry, I might refer to something, and there are more than one way to name it, and they're all correct. That's what's nice about math, is it doesn't have to be exact all the time. It's just got to be close. You might label it line PT. I might label it line SP. It's still the same line. So make sure you follow that. The next thing, collinear points. We already talked about that. Those are points that lie on the same line. Coplanar points, points that lie on the same plane. When we labeled 3 points that are on the same plane, like V, S, and T, those are called coplanar. Co because they're on the same what? Plane. Again, just like co-workers. Co, meaning you are the same. What are you the same? Workers. You're the same workers at the same company, so to speak. There's something called a line segment in math. Now, hopefully you've already identified this. Hopefully you already know what a line segment is. Line segment is a segment of a line that contains 2 points on the line. For example, on line AB lies line segment AB. I'm going to highlight it so that you can see it. From this point to this point is a line segment. The line segment stops at those 2 points. It goes no further off in space. It has a distance. We could measure it. Maybe it's X distance. Okay, maybe it's 2.5 inches. Who knows? But a line you can't measure because it never stops. Okay, although it might be confined to the paper, you can't actually measure it because it's going off forever. A line segment is exactly that. It's a segment of the line. It's a part of it. Just like if you watched an episode inside a season, like I love The Office. So if I watched episode 2 of season 3, that is a segment of Office. Okay, it's not the entire Office. It's just a part of it. It's a part of the greater whole. Just like a line segment is part of the line. There's another thing called a ray, and a ray is it's kind of like a hybrid. It's a hybrid between a line and a line segment. It contains a segment just like this. So we have AB. But then it also contains the part of a line. Maybe it contains this part of the line that goes on forever, where we stop at A but go this direction forever. We would label that ray AB. Notice how the arrow is above the B because B is the direction that goes on forever. Or maybe we use this line segment, segment AB, but we take this part of the line that goes on forever. We will label that ray BA because it's BA. Get it? Anyway. BA, and then A is the side that's going on forever. Now, here's a quick note. What do you think opposite rays are? Hopefully you know what a ray is now. It's a line segment with an end that goes on forever. It contains one end of a line. It can't be both, but just one end. And if they're opposite, what do you think that means? Hopefully you know that opposite means they do different things. Well, in this case, they go in opposite directions. You need to go away. Nobody wants you here. They go in opposite directions. So if I grabbed the ray that goes this way, the opposite ray would be the ray that goes in this direction, much like what I did. So I could say that ray AB and ray BA are opposite rays because they go in different directions. They're on the same line, but they go in different directions. They are opposites of each other. Hopefully that's not too deep. And again, I know a lot of this is new as far as its identity. Let's look at some different identities. Let's actually go through and rename a bunch. The first thing we want to do is, number one, give another name for line segment GH. Notice how this does not have the arrows going in either direction. So it is merely talking about the line segment GH. What is another way that you could label that line segment? You could merely flip the letters around and call it line segment HG. It's the same line segment. You couldn't, however, say JG because that's talking about a smaller segment, or HJ because that's talking about a smaller segment too. You want to still talk about the entire line segment, but if you just flip the letters around, instead of going GH, we could call it HG. It's the same line segment, just flipping the numbers around, or letters around, excuse me. Let's look at the same example. Name all rays with endpoint J, meaning J isn't the side that goes on forever. Now I'll give you a hint. There are 4 of them. Go through that diagram right there, that drawing, and see if you can label the different rays that have an endpoint of j. Pause the video and take a few minutes. Now I know the way it's written as far as with endpoint j, that can be kind of confusing. But what I do want you to notice is how there are 4 different rays going in different directions here. Each of those shares the same point j. That's because j is the endpoint. The endpoint is kind of that starting point. So for example, jg, or ray jg, starts at j and goes through g forever. Doesn't stop. Just like jh starts at j and goes on in that direction forever. je goes in that direction forever, but it starts at j. J is the end point. End point is weird. Why don't they call it the starting point? I'm really not even sure. It's considered the end point because that's where the line ends. The ray goes on forever in that direction, but the line ends at j. And the last one that we have is actually ray jf. It goes from here through here forever, but j is the end point. That's where it ends. Number 3 actually wants us to name 2 pair of opposite rays. We actually labeled all 4, and 2 of those are opposites. Can you identify the 2 opposites? Hopefully you see that G and H are on opposite ends of the same line, so the 2 rays, JG and JH, are opposite rays. Now you could have labeled that GH and HG also. We just already labeled them GJ and GH, so we're just going to flip it around. Just like JE and JF are opposite rays. They're on the same line, but they go in opposite directions. And again, you could have labeled those ray EF and FE, or GH and HG. That's accurate too. And they're opposites. Remember, there's always more than one way to do it. My way isn't exactly the perfect way, but it is one way. If you find another way, I'm not saying it's wrong, make sure it's correct. Give another name for line segment EF. So now we're talking about this line segment right here. What is another way that you could label line segment EF? And most of you are getting the idea. You just flip the letters around and call it line segment FE. Now let's go down here. We're talking about this diagram now. Name the intersection of planes A, which is this turquoise or teal color, with plane B, which is the gray one. Where do those 2 planes meet? Can you tell? They meet right here. Now what is that? It's a line. Those 2 planes, any 2 planes in the world, meet on a line. Look at the walls and the ceilings of your classroom or the room that you're in. The wall and the ceiling, any wall and a ceiling, or any wall and the floor, meet. They meet at what? It's a line. Any 2 planes intersect at a line, always. And so now we want to identify what that line is called. Well, there's 2 different ways we could do it. We could label 2 points that are on the line, or we could give the line a name. I already see that they labeled it K. That's line K. I could also use 2 points that are on that line. Are there 2 points on the line? I only see 1, and that's point M. So the only way that I could label line K is by calling it line K. Now let's look at another question. Name the intersection of plane B with line PQ. We're talking about this plane, and we're talking about this line, and where those 2 intersect. Can you see where they intersect? I hope you see that they intersect at this point, at point M. If you're having a hard time visualizing it, think of this. If you held up a piece of paper in front of you and took your pencil and stabbed it through the paper, if the pencil represented line PQ and the paper represented point B or plane B, how many times does the paper touch the pencil? It touches it once, and that's where the pencil goes through the paper. Just like line PQ here goes through plane B, it only touches it at one point, at point M where it goes through. And that one's kind of tough just because of the way it's drawn, but hopefully if you actually took a piece of paper and a pencil or a pen or whatever and had them intersect, you can see that wherever they intersect, it's only one point. And then number 3 tells us, name the intersection. Oops, excuse me. Name the intersection of line K and plane A. Plane A is in blue, or it's the turquoise. Line K is one that we've already seen. It's this line. Where do those two intersect? Hopefully you see that it's on line K. All of line K is actually inside of plane A. So every point on line K is actually inside, or it intersects plane A. This would be very similar to like taking a pencil and putting it inside a book. The pencil is inside the book. So how many points or how many parts of the pencil intersect the book? All of them. Just like line K is actually inside plane A, all of line K intersects plane A. You could think of it like paint. Okay? If plane A is a bucket of paint and line K is a stirring stick or something, if the entire stirring stick is inside the paint and you pull it out, the whole thing's going to be covered with paint. That's because the whole thing was inside the paint or inside the plane at some point. So all of line K intersects with plane A. Your homework tonight is just going to be like this. It's going to be identifying different parts of geometry. Maybe it's a plane, maybe it's a line, maybe it's a ray, or maybe it's a point. And making sure that you can identify them and label them correctly, because it's very important. If you're talking about the right wall, but you describe it like the left wall, well, I might get confused. Or maybe you're building a house and you're describing the basement, but the guy you're talking to thinks you're describing the attic. You know, you can really get confused there. So make sure you go through tonight's homework and label things correctly. Let's actually take a look at your homework now.